On the elementary electrical charge and the Avogadro constant. Physical Review, Volume 2, Number 2. By Robert Andrews Millikan. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Sections 1 through 4. Section 1. Introductory. The experiments herewith reported were undertaken with the view of introducing certain improvements into the oil drop method of determining E and capital N, and thus obtaining a higher accuracy than had before been possible in the evaluation of these most fundamental constants. In the original observations by this method, such excellent agreement was found between the values of E derived from different measurements, 1c, page 384, that it was evident that if appreciable errors existed, they must be looked for in the constant factors entering into the final formula, rather than in inaccuracies in the readings or irregularities in the behavior of the drops. Accordingly, a systematic redetermination of all these constants was begun some 3 years ago. The relative importance of the various factors may be seen from the following review. As is now well known, the oil drop method rested originally upon the assumption of Stokes' law and gave the charge E on a given drop through the equation 1, E sub n equals 4/3 pi times, open parenthesis, 9 eta over 2, close parenthesis, to the 3/2 power, times, open parenthesis, fraction, numerator 1, denominator g times, open parenthesis, sigma minus rho, close parenthesis, end fraction, close parenthesis, to the 1/2 power, times fraction, numerator, open parenthesis, v sub 1 plus v sub 2, close parenthesis, times v sub 1 to the 1/2 power, denominator capital F, end fraction, in which eta is the coefficient of viscosity of air, sigma the density of the oil, rho that of the air, v sub 1 the speed of descent of the drop under gravity, and v sub 2 its speed of ascent under the influence of an electric field of strength capital F. The essential feature of the method consisted in repeatedly changing the charge on a given drop by the capture of ions from the air, and in thus obtaining a series of charges with each drop. These charges showed a very exact multiple relationship under all circumstances, a fact which demonstrated very directly the atomic structure of the electric charge. If Stokes' law were correct, the greatest common divisor of this series of charges should have been the absolute value of the elementary electrical charge. But the fact that this greatest common divisor failed to come out a constant when drops of different sizes were used, showed that Stokes' law breaks down when the diameter of a drop begins to approach the order of magnitude of the mean free path of a gas molecule. Consequently, the following corrected form of Stokes' law for the speed of a drop falling under gravity was suggested. Equation 2. V sub 1 equals 2/9 times fraction, numerator, g a squared times, open parenthesis, sigma minus rho, close parenthesis, denominator eta, end fraction, open brace, 1 plus capital A L over A, close brace, in which A is the radius of the drop, L the mean free path of a gas molecule, and capital A an undetermined constant. It is to be particularly emphasized that the term in the brackets was expressly set up merely as a first-order correction term in L over A, and involved no theoretical assumptions of any sort.
Sample complete. Ready to continue?